Hi, this is your problem that you're looking at in your lesson on um, meaning of similarity theorems. And this is one question that you didn't get right on your first try here. So I'm going to talk about this one. And what I find helpful is instead of looking at it as one triangle with a line through the middle, I like to look at it as two different triangles. So I've redrawn this here. So here's your original picture right there. And if you consider, I'm going to go in and out of focus here for a second, but if you consider the smaller triangle and the larger triangle, so you see we have the smaller triangle here, we have the larger triangle here, ABC and ADE. See if I can have it, try and focus again. There we go. We can kind of see that side AB and side AD match. One's going this way, one's going that way. So they kind of match up. We call those corresponding sides. And here's how that relates to your problem over here. AB and AD are corresponding. They match up. On that same way of thinking, DE and BC. Where is it? DE and BC. They also correspond. They match up. On the bottom, on the bottom of your options, A, B, C, D, on the bottom, AE and AC, they also match up. AC is right here, AE right there. They match, they're corresponding. The ones that don't are CE and AC. CE and AC, yes, they're on the same line here, but CE is not an entire side of a triangle. It's just kind of like part way down, halfway maybe, but it's hard to tell exactly. CE is not a side on either triangle. So that's why this third option here is not, that's what it says here, all the following are equivalent to each other except the one that doesn't work. So with that same idea in mind, let's look at number 4 here. So they've given us some values. They've said that BC is 6, DE is 9, and then they want to know which of these could be the lengths of AB and BD. So I know you can't see what I'm writing here. I'm going to put AB and AD there. Okay. So here's my image. There it goes. So 6 and 9, BC and DE, they match up. They're corresponding to each other. So what I'm going to do is I'm going to set up a proportion. I'm going to say 6 and 9 match up. So that's a ratio, I guess, right now. Ratio. And I'm going to say that's got to be equal to, let's see, I did 6 and then 9. So I read from the small triangle to the big triangle. Now I'm going to read from the small triangle to the big triangle. And I'm going to say that's got to be the same as x and y. Okay, so going back here. Which of the following could be the lengths of AB and BD respectively? Let's try 2 and 3. It's the first one. We'll give it a try here. If this is true, that means that if I put 2 here and 3 here, that should work. Let's see, 6 over 9, 2 over 3. There's a couple of ways you could try to do this to see if that's true. If that's true, then we've got it. It's got to be problem A. One way you could do it is you could reduce 6/9. Can you reduce that fraction down to 2/3? Let's see, I could do divided by 3 and divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Yes, 6/9 is equal to 2/3. By reducing that fraction, I can see that 6/9 is equal to 2/3. So A does work out to be the correct answer. Just to show why B does not work, if I do 6 over 9 and I use 3 and 4.5. So that is the option you've selected here, that this works. I could do 6 divided by 2 to get 3. I could do 9 divided by 2 to get 4.5. That would work. If BC is 6, DE is 9, which of the following could be the lengths BD? Oh, I apologize. I was not reading this very well. It says AB and BD, not AB and AD. So those letters messed me up there. I wasn't paying attention. This would work for AB and AD, but not BD. BD has an extra little hiccup there. Okay, well, let's see. If let me try and explain this thing because I probably confused you. This is how we set up a proportion to solve if we have the sides. This one added a little complication, so ignore that piece right there. And let's go with A again because we'll try 2/3, or 2 to 3. So I'm going to try 2 to 3. If AB is 2 and BD is 3, so AD is 2 and BD is 3. That means that, and again, this is 6, and that's 9. So you have the small, the big, 6, 9. This is going to be 2, but this whole side here, AD, wouldn't be 3. The whole side would be 5. That's 2, that's 3. This whole side here would actually be 5. So now our question is 6 over 9 equal to 2 over 5? Not 2 over 3 like I did over here, because I assumed that this whole side AD was 3, and that was wrong. I read the letters wrong. If just BD is 3, that means AD, that entire side, would have to be 5, and no, it's not going to work out there because that should be a 3. So that does not work. All right, let's look at the next one. 3 and 4.5. All right, so now this is 3, and this is 4.5 there. That means the entire side is going to be, what, 7.5. So that's 3, and that's 7.5. And I got 7.5 because 3 and 4.5 together is 7.5. So my new question is 6 over 9, 3 over 7.5. That's my new question. And we kind of saw it before that it really should be 3 and 4.5 because 6 divided by 2 is 3, 9 divided by 2 is not 7.5. So that didn't work. All right, we got to try the next one. This is getting kind of messy here, so I'm just going to scratch these out. It said 4 and 2. So this is 4, and that's 2. So I'm looking at C on the options there. That means that AB is 4, and this whole side would be 6. 6. So now my question is 6 over 9 equals 4 over 6. Ooh, you can't see that. There we go. 4 over 6. Okay. Well, 6 divided by something is 4. That's a little harder for me to think about in my head. Back here I did 6 divided by 3 and 3 divided by 3. I did 6 divided by 2 and 9 divided by 2, because those are easy numbers for me to figure out in my head. 6 divided by something is 4. That's a little more difficult to do in my head anyways. So another option that we have is we can, with a proportion here, we can cross multiply with a proportion. And the way that works is we do 6 times 6 is 36. 9 times 4, also 36. Hey, that worked. 36 actually equals 36. So this cross multiplying is another way to test whether the proportion is equal. We could have tested it here. 6 times 5 is 30. 9 times 2 is not 30. 9 times 3 is 27. 6 times 7.5, definitely not 27. So that cross product is another way of testing to see if that proportion works. So in this case, 4 to 2, that was the ratio between AB and BD that gives us a proportional side between those sides AB and AD. All right. Hopefully, I didn't confuse you too much with that initial issue, and you can see at least how we set up these problems. I highly recommend redrawing the triangles as a small one and a big one. As you can see, it can get very complicated very quickly, and having the pictures helps a lot. Set up a proportion and try and solve it from there. Let me know if you need more help, and I'll make a hopefully more clear video for the next one.